In this example, we're going to use the specific heat to determine how long it takes to boil a pot of water. So let's begin. How long would it take an 800-watt coffee pot to bring 0.8 liters of water to boil if it was initially at 25 degrees Celsius? So the water as well as the coffee pot was initially at 25 degrees Celsius. Assume that no water boils away, so the mass of the water remains constant, and assume that the pot has a mass of 0.3 kilograms and is made of aluminum. So let's begin with step one. It's step one. We essentially want to ask ourselves how much energy is required by the coffee pot to increase the temperature of water and to increase the temperature of the pot to 100 degrees Celsius from 25 degrees Celsius. So first we have to calculate the energy requirement. So the total energy required by the coffee pot is equal to the energy required to increase the water to 100 degrees Celsius and the energy required to increase the coffee pot to 100 degrees Celsius. So for this case, the equation is as follows. Recall that the amount of energy transferred, Q, is equal to the product of the mass, the specific heat, and the change in temperature. So the Q of water is equal to the mass of the water multiplied by the specific heat of water multiplied by the change in temperature of water. And likewise, the amount of energy required to increase the coffee pot, Q pot, is equal to the mass of the aluminum pot multiplied by the specific heat of the aluminum multiplied by the change in temperature. So notice the change in temperature for both cases is 75 degrees. We go from 25 degrees Celsius to 100 degrees Celsius. Now, what about the mass of water? Well, the mass of water is determined by taking the density of water and multiplying by the volume. So we know the density of water is 1 kilogram per liter. So we take the amount in liters, 0.8 liters, and multiplied by 1. The liters will cancel and we're left with 0.8 kilograms of water. And since no water boils away, the mass remains constant. Now, the specific heat of water is 4,186 joules per kilogram times Celsius. And the change in temperature is 100 minus 25, so 75 degrees Celsius. Now, what about the coffee pot? Well, the aluminum coffee pot has a mass of 0.3 kilograms. And we know that the specific heat of aluminum is 900 joules per kilogram times Celsius. We can find that value in a textbook or online. And the change in temperature is also 75 degrees Celsius because initially the pot and the water are at the same temperature. So we multiply these two out and we get the following result. So we add these two quantities and the total energy required is 271,410 joules of energy. So now we move on to step two. In step two, we want to use the equation for power. So power output, which is given in watts, is equal to the change in energy divided by the time. The energy is given in joules, the time is given in seconds. So we take this equation, rearrange it, and solve for the time. So the time is equal to the change in energy divided by the power. So we know the change in energy is equal to this quantity, and we know the power is equal to 800 watts or 800 joules per second. So that means we take this quantity found in step one divided by 800 joules per second, and that gives us the time in seconds. So it takes our coffee pot 339 seconds to increase the temperature of water from 25 degrees Celsius to 100 degrees Celsius. And equivalently, that's about 5.7 minutes. So it takes our coffee pot 5.7 minutes to boil the water.